Hey everyone, this is Ben. Welcome back to my Leetcode series. So today we're going to be working on problem 1817, and we're going to be coding this in Java. So this is a fun problem to kind of challenge your knowledge on hash maps, and as you can see, it is a medium level problem. And I think that's because we're manipulating a hash map in a traditionally different way that you don't do in easy problems. So let's go ahead and read the prompt together, and then we will talk through the pseudocode and we'll code up a solution. So you are given the logs for a user's actions on Leetcode and an integer k. The logs are represented by 2D integer array logs, where each logs I equals ID I and time I. And that indicates that the user with ID I performed an action at the minute time I. Multiple users can perform actions simultaneously, and a single user can perform multiple actions in the same minute. The user active minutes, UAM, for a given user is defined as the number of unique minutes in which the user performed an action on Leetcode. A minute can only be counted once, even if multiple actions occur during it. So right there, a little flag, we're going to be working with unique values, and I'll explain that here in a little bit. Now, we're to calculate a one-indexed array of size k. So for each j, 1 is less than equal to j less than equal to k. Answer j is the number of users whose UAM equals j. Now return our answer array that was described above. So we're going to talk through the first given example, and then we'll type up some code together. So just going into some of the pseudocode here. First off, we have, this is our log 2D array. And remember, our 0th position within our 2D array entry is our user. And the second entry will be our time, so the minute mark that the user did an action. And our k equals 5. So as the prompt describes, the first thing we need to do is create our one indexed array of size k. So all we have to do is create an array of size k. Very easy. Again, logs I equals ID and time. And the user active minutes, UAM, is the number of unique minutes that a user performed an action. So my approach, what came to mind first, is to use a hash map with an integer key, and that key will be our ID, and a hash set of integers as the value, which will be our times. So we can iterate through the logs to the array, and if the map doesn't contain logs I0, which is the ID, we can add it to the map and create a new hash set for it. Then we can retrieve the hash set at key logs I0, and we can just add logs 1i to that hash set. Now remember, a hash set only stores unique values. So we'll be able to store unique value minute marks for each user ID this way, and there will be no duplicates. So that solves our issue of duplicates as described in the prompt. So let's go ahead and create a for loop for every I that's in logs. Now when I equals 0, we're going to pan up and down to this example here. Does map contain the key 0? No, because our hash map is empty. So I guess we need to add, we need to create our hash map as well. Create the hash map. So the map is empty. Does it contain key 0? No. So we put 0 in the map, and we're going to create a new hash set as its value. Now what we do in that same iteration is we retrieve the hash set of key 0, and we add 5. So now you can see our map right here. 0, and it contains a hash set of 5. 1 is the same process. 1's not in the map, so we need to put it in, create a new hash set, and as you can see, we retrieve that hash set, add the value 2, and here we go. Now when I equals 2, this is a little bit different because the map does contain the key. So our if statement we can skip entirely. We go straight to retrieving the hash set of key 0, and we add 2. So now you can see our map, 0 has 5, 2. Now going down to 3, same thing, we already have 0. We just need to add the value, but notice that value is 5. So when we add the value in, nothing changes. We still have 5 and 2 because the hash set will not store duplicate values. Going down to I equals 4, yes, we already have key 1 in our map. So we can retrieve that hash set, and we can just add 3. So this is our final map right here. Now that we have our values, we just need to store them in our final array that we're going to return as a part of this method. So we need to store an ID's UAM at the appropriate one index position in our final array. So if our final array starts as null, basically all zeros in each index position, and we can use a for loop to iterate through our map and our map key set. And what we're going to do is our map.getI.size. So that's how you retrieve the size of the hash set associated with our key, which is I. That is our index, but we also need to subtract 1 because remember this is a 1 indexed array. So what I mean by that is we're keeping a tally of UAMs. So in our first position, which is index 0, this represents all users that have a UAM of 1. And then we just go so on and so forth. So at I equals 1, which is right here, this represents all users that have a UAM of 2. So what's going to happen here when I equals 0 within, tabbing out, within this map here, so we'll say map.getI, which is 0, dot size minus 1. So that's 2 minus 1 equals 1. So that takes us to this index here, which is correct because we want to store the amount of users with a UAM of 2 in the second position in the array, which is the first index if we're going by true indexing. So that is pretty easy. All we have to do is just plus, we just iterate it. Now going down for I equals 1, which is our only other key in the hash map, we do the same thing. We call map.getI.size minus 1. That is going to be our index position in our array, and we just iterate it by 1. So our final array is 0, 2, 0, 0. That's because we have 2 users who both have UAMs of 2, as seen in our final hash map right here. Okay, so let's go ahead and code up a solution. So notice how we have to import the hash map library. So make sure you do that before running your code. Now we'll say int result equals new int k, because that's what the prompt says. We need to return array of size k. We'll create a hash map, integer, and then notice how I'm going to do hash set integer as our value in this map. Now going to our for loop, for int I equals 0, I less than logs.length, I plus plus, and immediately we have an if statement. So if our map doesn't contain the key of logs I 0, we will go ahead and put it in the map, and we'll give it a hash set that's null as its value. And then we'll be able to call on this later. So we can say new hash set integer, just like that. Now, no matter if that if statement catches or not, the statement at the end will always remain the same, which is map.get logs I 0. And we'll say dot add. So this right here is returning our hash set to the appropriate key of logs I 0. So we need to add to our hash set when we have a value each time, which is the time, the minute mark that we're adding. And now, so that completes that. So now we're going to iterate through our map. And as we described in our pseudocode, I gave the direct code here for this, map.getI.size. So that's going to return the size of the hash set associated with our key. And we will subtract 1, because remember we have to offset for our 1 indexed array. And we'll just iterate that. So we're just adding 1 to that array position. That's all we're doing. Then we can just return res. So if you're confused by this for statement, if we don't contain the key, we throw it in with a new hash set, right? So for our first iteration, when our map is empty, we don't have a key. So we'll create a new hash set. And then once you get down here, that's when we'll add the time value. So no matter what, the time value is always being added for each iteration. So let's go ahead and run the code. Now, as you can see, everything turned in successfully for the test cases. And this was my submission with this code. As you can see, it was 97% faster, 86% less memory usage than other users. So this is a pretty tough little problem once you think through it. But being able to utilize your hash map with a hash set as a value makes it a lot easier. So thank you very much for watching and have a great rest of your day.